I don't know about you, but I've noticed something. We're becoming a digital age more and more. Music, digital. The video, digital. Everything, email, everything that we want to do these days, it seems like it's a digital media. And we're converting our non digital stuff to digital all the time. And what does this mean? It means that storage is a bigger deal for us than ever when it comes to information technology. In this nugget, you and I are going to go through some history. We're going to take a look at many forms of storage, but I want to start by discussing what are our concerns when it comes to storage. So you and I are A+ whizzes, which means we need to be familiar with optical media, mechanical type stuff, type stuff, solid state and flash technologies. But before we delve into these specifics when it comes to storing our stuff, I wanted to talk to you about the characteristics that we would care about. I guess first would come to mind cost. Yeah, we know that different technologies for storing our stuff are going to cost varying degrees of expense. So this is something that we would consider. How about the lifetime of that particular media? So if we were going to burn something that we really cared about to DVD, we would wonder, how long does that survive? How long until the DVD breaks down and we can no longer read that? What about tape? It seems like tape would break down and be unreadable even sooner than optical. And sure enough, it would be. Another thing we would wonder about would be performance. If we have a lot of stuff that we want to archive to an optical media, is that going to be too painfully slow compared to other options? How secure is it once it hits that media that we're using to back things up? So these are just some of the concerns that we would have, and they're going to govern what we're doing and what we're choosing as far as the storage that we use in our daily plan of information technology. And let me just make a quick intentional pun. I left out a pretty big one, a big concern that we would have, and that would be size. How much stuff can we store on a media that we choose? And let's just do a quick review of how we measure that. Remember, the central component, the central size of digital information is a bit. That's a 1 or a 0 setting. When we gather 8 of those together, we have a byte. When we have roughly 1,000 of those, we have a kilobyte. When we have roughly 1,000 of those kilobytes, we have a megabyte. Have 1,000 of those megabytes, you have a gigabyte. Then a terabyte, then a petabyte, then an exabyte. You get the idea. And the oldest joke I have from my training days is, if you get bigger than an exabyte, you have a Mike Tyson byte. And thankfully, Mike Tyson has stayed around in the media all these years, so that joke still works. If you don't get it, just Google Mike Tyson byte, and you'll catch on. And by the way, that byte is B-I-T-E. But I digress. We notice that different things today that we want to store are going to fall somewhere in here on this size chart. For instance, if you want to download the live version of Freebird, well, you're dealing with a song that's probably going to be about 8 megabytes in size. If you're ripping a movie from DVD, you're going to be dealing with a file on your drive that's going to be 4 gigabytes in size. So one of the things that we do when we're deciding on the storage media that's going to be perfect for us, we look at what it is we're storing. If you have someone that says, yeah, we take an amazing amount of photographs, digital photographs, and they're high def, so each one is about 1 megabyte in size, and we take hundreds of photos every week that we want to store, you begin to see the size of the storage that you're going to need in order to accommodate that individual. By the way, one thing that can get really confusing about this is the bit and the byte both have a B designation, but what we like to do in the documentation for things like speeds and storage capacities of digital information, we like to do a lowercase b for bit and an uppercase B for byte. So if you see MB PS, for instance, it would be megabits per second. If you see it as MB Mbps, it would be megabytes per second. There's obviously a slight difference between a bit and a byte. One is the single component of a 1 or a 0, and a byte is 8 1 or 0 settings. So this is, while a slight difference, it is important to be speaking about the correct terminology when we are looking at abbreviations like this. So the first major category of storage we want to focus on, though, is optical. So we are using a laser. We're not doing it, thank goodness. The drive inside of our computer, or even an external drive that we attach to our computer, is using a laser to write on the surface of this media. Wait a minute, though. It doesn't always write. You can have just CD-ROM technology, or DVD-ROM technology, or Blu-ray technology, where you can only read using the drive from the media. What's exciting is there's CDR technology, and the R stands for writing. Wait a minute, though. This says CDRW. What's going on there? Well, that's writable, but also rewritable. So they decided to designate that with the RW designation. And this is great because we could burn some information, as we like to call it, using the laser to the optical media. And then we could come back later and rewrite information to the optical media. Notice that works with DVD technology as well. It works with Blu-ray discs. There's a writable and then there's a rewritable Blu-ray disc. So all these different generations of optical technology. We started with CD-ROMs, then we created DVD-ROMs, then we created Blu-ray, then the writable and rewritable versions of the Blu-ray disc. What's going on here? Well, really, increases in the technology to increase the available storage space. We're talking roughly like 600 megabytes of storage space with the old CD-ROM technology. Notice I said roughly. It might not, maybe it's 650, I don't know. And I'm demonstrating right now how well you would need to know something like that for your exam. The great news is in the A+ certification exam, we don't have to get hung up in memorizing all these specifics. There would be simply too much for any one human to memorize. With DVD-ROM technology, we can get into 4 gigabytes of storage space. With Blu-ray, we start getting into 25 gigabytes of storage space. So the great news is, as these technologies progress, we can store more and more stuff on one optical disc. Now, there's another piece of terminology here with optical storage we need to be aware of. It's really exciting. It's DL. DL stands for dual layer. And this is technology where we can essentially write twice as much stuff to the media. I have some of these in my office right now because they're great. We jump up to 8 gigabytes of storage space, for example, if we were dealing with DVD dual layer technology. So, CD-ROMs were great, but couldn't store a lot. Notice we couldn't even fit a high-def movie on a CD-ROM. Then DVD-ROMs came along, store more stuff, dual layer, great. Then exciting Blu-ray capabilities. By the way, Blu-ray is exciting to many of us, of course, because that's how we're used to watching movies. The movie companies will put their media onto Blu-ray for us, and we'll go down to a Redbox or however you rent Blu-rays or purchase a Blu-ray disc, and then you pop it into your Blu-ray player connected to your television, and you experience this incredible sound and this incredible definition because there's more data they can store on that much bigger disc. I'm so trained when I think of optical media for storing stuff, I immediately think not of movies and stuff, I think of me putting data on there. Let me describe quickly how I might use optical storage. In fact, I shouldn't say might, it's how I do use optical storage today. So I'm working on this A+ course, and the A+ course has all of these important files in it that I am utilizing in order to create this course for you. I work out of a Dropbox folder. So I am working right now out of Dropbox. Everything I create, everything I do is being synced up to the cloud thanks to the good folks at Dropbox. So I'm backed up. I have a local copy, and then I have the copy up on Dropbox that gets automatically synced. So I can sleep well at night because I'm backed up. I have my data in two different places, and backup is obviously a huge element about storage today. Now, once the A Plus course is done, I will take it out of the Dropbox. I'll leave a local copy, but I'll take it out of the Dropbox and I'll move what was the Dropbox copy, if you will, and I will burn that to optical media and I'll stick it on my shelf. So I have it in two places still. I took it out of the cloud Dropbox and I put it on my shelf as burned media, and I still have a local copy. Now, to be really safe about this, I move the optical discs to my remote office so that I have the data copied in two different locations. Goodness, I hate to think about it, but if my main office burns down, I can't have my local copy on disk be burned away in a fire along with the optical media. So we separate those two. That's another nice technique. So a lot of people would look at this optical media section and they would say, yeah, well, that's cool, Anthony. It's great that there's a laser that can burn our information to disk and even rewrite that information to disk. But who would do that anymore? I mean, that's old school. That's silliness. Well, no, there's great use for this, like I'm doing it, to archive information that you want to go ahead and stick on a shelf. If you buy the blank media in bulk, like if you go and you buy 1,000 DVD ROM rewritables, you can get them very inexpensively per DVD. So this is inexpensive storage. The lifetime, it'll probably be about 50 to 200 years before your optical media is no longer useful, before the data can't be read anymore. So just keep that in mind. 50 to 200 years. That's probably going to be just fine for most of us when it comes to archiving information. Why is there such a tremendous variety in the amount of time? Why does it go from 50 to 200? Well, it really depends on the quality of the optical media that you bought, the quality of the drive that you were writing the information with, the care that you take of the media. Like, do you keep it dust free? Do you keep it temperature extremes free and all that kind of stuff? Are you sealing it up in a nice case? So how you protect and how you care for that media is going to make a big difference. By the way, the other big thing for us here is the drive itself. So when we are equipping someone with their computer, we have to make sure the drive does the type of optical media technology that they want. How embarrassed would you be if you built a computer for someone that wanted to use it as a media server to play movies and share photographs and things in the living room, and you forgot to include a drive that could play Blu-rays? You would be very embarrassed because they would connect this computer that you sold them. They would put a Blu-ray disc into what is probably only a DVD-ROM type drive. It would not function, and they would be quite upset with you. So we got to find out what someone's going to be doing from a storage capacity and then rig their system, outfit their system with the appropriate drive. Apple sells what's called like a super drive. I think they literally call it a super drive. And why they call it a super drive is because it speaks an amazing number of these languages, so you can use a lot of different media with it. Now, come on, be honest. When I said we were going to talk storage, you immediately thought hard disk drive. Sure, and that's why I created that great, I certainly didn't create it, but there's that incredible animation from our illustrator here at CBT Nuggets, Amber Barker, daughter of Keith. She created that beautiful illustration of a hard disk drive. Of course, that's what you thought of. And hard disk drives, you're going to have really two concerns. Number one, they're coming way down in cost. So that's not the big concern. Your concern, of course, would be how big is it? How much can it store? And you might also be concerned with speed. And here you can see the RPM, the revolutions per minute or rotations per minute that hard drive that you may purchase can accomplish. 5,400 RPM, 7,200 RPM, 10,000 RPM are example speeds. The faster the disk, the platter or multiple platters inside the hard drive can spin, the faster this little read-write head can go over and read the magnetic information that it needs to write or read data. And this makes a big difference in the performance, how fast those platters are spinning. By the way, another big concern, though, for us with hard drive purchasing and outfitting for our equipment is going to be the connection technology. In another nugget, I forget which one, not relevant, but I mentioned how there used to be IDE hard drives, and now today there are SATA hard drives. And we were obviously, now I realize, talking about connections that are available on your PC. So you would want to be concerned with, okay, am I outfitted for SATA connections, and am I going to buy this really fast SATA hard drive? But our biggest concern is the lifetime of the hard drive. It's not if it's going to fail, it's when it's going to fail. And remember we said the optical media can keep our stuff alive and safe for us for 50 to 200 years by most estimates? There's not any hard drive you would ever find right now, mechanical hard disk drive we're talking, that would last that long. If you're using it every day, there's no way you're going to get 200 years out of it. So now we begin to think about, okay, we do need a lot of different solutions when it comes to our storage today. The hard drive is great for initially working with the data, but then we want to get a copy off to optical media because we know that hard drive's going to fail. Maybe we're scared we're going to lose those optical media, so we put a copy in the cloud. Maybe we're afraid that cloud vendor is going to go out of business, so we put another copy somewhere else. And you're beginning to see how storage gets very complex, and we use a lot of different storage techniques in environments today. Now, in an enterprise, real professional computing environment, we're not going to have these hard drives inside of traditional cases where we have to rip off the PC case and go in there and find the hard drive. No, the hard drives will be very obvious on the front of like a blade server. Here we can see a blade server from Cisco Systems. This server just slides right into a rack inside of your server room and mounts there. And what's really interesting is we can see right on the face of it a whole bunch of hard drives. Let me zoom in as far as it'll take me, and I can see that they look like 500 gigabyte, 7,200 revolutions per minute SATA drives. And what's amazing about these drives is that they're what's called hot swappable. We can have one of these drives fail. Look at how many of them there are. In this machine, it looks like there's 1, 2, 3, 4, 5, 6, 7, 8 of them installed. And if one of them were to fail, we can go release a latch, slide out that hard drive, and slide in a replacement with no one ever being impacted. No user that's using the data stored on this server would be impacted. That's amazing. That's what's called hot swappable. In fact, Cisco designed this device so that we don't even need a tool. So we don't even need a screwdriver. It's called toolless hot swappable drives. One fails, inevitably like it will. This has no impact on the information you're storing for people. You just slide in a new one. Cisco will also color code, by the way, these blade servers so that if there's like a green icon on it, it means it's hot swappable. If they use some other color, it would mean you can't hot swap it. So shut it down before replacing that piece of equipment. So in this first part of our journey through storage, we've taken a look at optical drives, magnetic drives, and hot swappable drives. In the next nugget, we'll be sure to take a look at technologies like solid state disks. And also, what about tape? What role does that still play in some environments today? I sure hope this nugget was informative for you, and I'd like to thank you for viewing.